Good afternoon, good morning, everyone. I'm Andy Bensley from Genelec, and thank you for joining us today. This is one of our first webinars of a series, and kind of owing to the current situation we all find ourselves in. This first webinar is about trying to improve the way our systems and our setups sound at home. So we may have found ourselves in a position where we're having to work from home, or certainly kind of compose, mix, write at home. So hopefully we can kind of work on a few things to kind of make your experience a little bit more rewarding, a bit more fulfilling, and with a bit of luck we can kind of improve the sound of your home studio. So a little bit about me. I'm based here in the UK. I'm speaking to you now from my home in the north of England. And my involvement with Genelec, I've been working with them for just over a year. And previous to that, I was working for the UK distributor. My background is primarily in calibrating systems and advising customers on the right systems they should use for the rooms that they're working in, as well as trying to get the best out of those systems. So kind of when I was at my busiest, I was probably going into, I don't know, 150 rooms a year. So a lot of rooms, and that was kind of big recording studios, post-production facilities, but also a lot of customers' homes. So I've got a lot of experience of working in smaller environments, working in environments that are kind of less than ideal, really. So hopefully we can discuss a few things to try and improve the way that we're working at home. One thing I'd like to flag, I'm not an acoustician. A lot of my experience is kind of practical applications of how we would set up monitors, how we can kind of find ways to improve and work with the rooms that we have. So what we'll do, I'll dive into the presentation, and then at the end we'll have a Q&A. Before I start, I just want to thank everyone for a lot of questions that I've received this morning. I've had emails from Singapore, France, Germany. And it's been fantastic to speak to everyone so far. But if you've got any questions, please feel free to throw them into the text box, and after the presentation we'll be able to have a chat and have a bit of back and forth. Okay, thank you. Right, let's dive in. So here we go. Where are we? Right, so improving the sound of our studio. First thing we'll have a quick look at is selecting the right monitors for our room. And this is kind of down to making sure that we've got the correct amount of performance, the right amount of low frequency extension we might want, and also finding the right location, because I think one of the big things that we struggle with when we're working in less than ideal environments is finding somewhere that works sonically but is also convenient. So a lot of us will be repurposing rooms that may have been spare bedrooms or kind of living rooms, but trying to find a space and trying to look for areas of the home that we could use that are going to sound good, that are going to ultimately let our projects translate. Then we're going to move on to looking at some basic acoustic improvements that we can make, and then finally we'll talk briefly about calibration. Without the foundations of correct placement, additional acoustic treatment, the calibration side of things becomes quite difficult. If we've got a good foundation in place with all of these, then we can kind of add that extra 15–20% with the calibration, where we can take a system from sounding okay to sounding really quite excellent. So selecting the right monitors. One thing that we are very passionate about at Genelec is ensuring that you get a great monitoring system, but mainly that it works in the space that you're intending to use it in. And a lot of that starts with initial conversations about selecting the right monitor, selecting the right size. Do you go with a subwoofer? Do you not? So we've got online a number of different aids that we can use. Obviously, you can speak to a Genelec representative in your local territory or a distributor. But if you go over to the Genelec website, genelec.com, you can find loads of information to kind of help you out. So this table is very useful here. We can kind of see a large selection of our models, our two-way speakers, like this 8040 here, our three-way speakers, and then some of our larger stuff as well. And this chart basically gives us ideal listening distances. So listening distance is something that we talk about an awful lot in terms of giving ourselves an accurate monitoring system. The last thing we would want is a monitoring system that wasn't capable of throwing a certain distance. If you're sitting 2 meters away and we've got a tiny speaker and we're expecting to hit 100 decibels, we're not going to do that. We need to be very realistic about where we position ourselves, where our listening position is going to be, and what monitor we choose to kind of carry out the task in hand. This is really, really important when we talk about mixing and editing. Well, mixing mainly for post-production, that we might want to hit a certain standard. So generally that could be 85 dB. So we would look at along here and say, okay, 1.5 meters, oh great, all of these monitors will hit that. As we start to move further and further away, we start to see it getting a little bit tight at 3 meters, etc., etc. One thing I'd like to quickly mention is where we would set our monitors up in terms of height. I've got some slides on this later on, but one thing I'd just like to raise your attention to is with a lot of our two-way products, we have this acoustic axis, which is here. So we would have that as our ear height. At this point in the room, so say for example, if we take this 80/40, at 1 meter, that would be its optimum listening distance to begin with. So what will happen there is that tweeter and that woofer will align perfectly. So what we'll get is an even frequency response 1 meter away from the speaker. If we look at our 8341, this compact three-way design, we've got a tweeter, a mid-range driver, and we've also got concealed woofers top and bottom. If we go to 8341, see that listening distance is much shorter. So what we can do is use these in a much more near field situation if we needed to. We're not restricted by having to give the monitor some distance to get these elements aligned here. So it's just something that's worth thinking about when you're setting up a listening room, where your listening position is versus the amount of horsepower and capability that your monitoring system has. We've also got useful guides on selecting and pairing subwoofers with systems. This is just a quick overview of some of the specs, but where it becomes interesting is when you start to look at specific models and then the subwoofer that you should pair it with. It's a combination of the amount of low frequency extension that you would require, but also the amount of headroom. So you wouldn't pair an 8010 with something like, I don't know, something like a 7380, for example. That subwoofer is way too powerful for that monitor. So what we do is we kind of have these charts in place where we can have 8341 paired with 7370, and that will give you a complementary subwoofer that will work nicely with that monitor. Okay, so finding the right position in the room. This is absolutely key to establishing the foundation of our monitoring setup. Because we're kind of spending a lot of time at home, this might be an ideal position just to kind of experiment with some new positions. Not just setting up where it's convenient next to power sources, maybe just having a look around the room and seeing where there might be some additional options where you'd experiment with your positioning. And then we'll move on to looking at the right location for your listening position. Again, as we said previously, that feeds into the monitors that you're using, how much headroom you've got, how much SPL they can create. So a key element of placement in any studio, in any room, is symmetry. If we've got balance in the room, for good or for bad, then we will have a similar experience on the left speaker and the right speaker. Okay, ideally we would have a room that was balanced in tone, that was balanced in acoustic treatment, and we would be able to get a balanced reproduction from the monitoring system. So it's important that the left-right symmetry is accurate and create an accurate stereo image. Left-right symmetry makes early reflections similar on the left side and the right-hand side. So say, for example, if you've got a bad room, but it's balanced, that can be quite a good thing because you're going to get the same auditory experience from the left and right speaker. And then any acoustic treatment that we would add should be replicated on each side. So again, symmetrical placement of treatment is very important. What I'm going to take a quick look at is just some examples of just some setups that we might typically see. Apologies if this is anybody's setup. I'm not picking on anyone. This was just something I found on Google earlier. So just by looking at this setup, I would predict, and I'm pretty certain that this monitor here would have an excess in low end because we've got a boundary behind it and a boundary to the side. Whereas we look at this right-hand monitor, it only has one boundary to act on. What we'll generally see with corner placement is a boost in the low frequencies of around 12 to 15 dB sometimes. This monitor against the wall, we might see 8 to 12 dB. So conservatively, you might be seeing a 6 to 7 dB swing in terms of excess low end. So that's going to have real issues in terms of the balance of the system, your ability to make accurate decisions on what kick drums and what bass guitars are doing. So just by moving that speaker, or the whole desk rather, to the right, more into the center of the room, would really, really improve things there. We've got a mirror on the left-hand side, which is at ear height. So again, we're going to be getting different reflections from the left-hand side versus the right-hand side. That's going to affect our stereo imaging. And even now, if you sat there, if you were to start talking and put your hand over your left ear, you would hear a difference. You would hear a difference in more of a claustrophobic sound on the left-hand side versus the right-hand side. And this is exactly true of when you're placing monitors in a room. Similar setup here. The left-hand monitor will have an excessive low frequency response compared to the right-hand side. Again, we've got two boundaries that it's working on, here and here. This one has a window behind, so that might have a very, very different frequency response in the low end. You may hear reflections and resonance from this shelf on the left-hand side. Again, we've got a wall versus an open space. Monitors on the desktop. So if we were talking about the acoustic axis, which on these Yamahas may well be there, if we're sitting at ear height, which is there, we're not going to get the information that we need from the tweeter and the woofer arriving at the same time. So there's a few things that we could do with that. Another example here is a more symmetrical setup. So instantly, the whole system just looks more balanced. They've raised the monitors up off the desk, which is great. So we've kind of got that acoustic axis, which is kind of hitting at the ear height. We've got a nice equilateral triangle there. This synth rack here is positioned kind of behind the monitoring position, which is excellent. And we've got a nice low console here. So on the whole, that's quite a nice balanced setup. I mean, even just looking at that, you just know that it's gonna sound pretty good. So this space is my room where I'm talking to you now. And this is a very, very small room. It's kind of 2.5 meters across, 3.5 meters deep by 2.5 meters tall, something like that. And one thing that is really beneficial about this room is it's so small that I haven't got a choice of where I put things. This is kind of, I had to cut down this desk to fit it in. But what it does give me is absolute symmetry on each side of the room. And as a starting point, gives me a really good baseline of which to kind of add treatment, to kind of experiment with the placement of the monitors and also the height. So we're going to look at some recommendations of where we should place them place the monitors for a stereo setup. So ideally, we should aim for the front third of the room. This is going to give us kind of two main benefits: that we're not exciting this rear part of the room where we'll generally start to see some buildup of low frequencies. But if we put them at the front of the room and we put our desk at the front of the room, we've got a nice kind of close proximity to them, to the monitors. We try and use a room orientation that offers the best left and right symmetry. Again, what affects the left affects the right. So if we can kind of mitigate those issues by having symmetrical placement, equal distance from the back wall, equal distance from the side walls, this monitor should behave quite similarly to this monitor in theory. We should place the monitors symmetrically at 60 degrees. This 60-degree value here can be tweaked. It can be a little bit narrower, slightly wider, but this 30 and 30 will give us a good illusion of a stereo image. And what we want is obviously information to appear in the left speaker, information to appear in the right speaker, but also a nice solid phantom center where vocals are real, kick drums are nice and defined and punchy, and that we've got a nice center foundation in the stereo image. We should point them horizontally and vertically towards the listening position and make sure that this distance from here and here to the listening position is as close, if not exactly the same as possible. Again, that helps to create this illusion of a stereo image. We should try and position the monitors away from the wall. Again, this is to help with boundary loading. A frequency response that we might typically see from a speaker placed against the wall is something like this, where we have a really big boost in the low end and then a relatively flat response everywhere else. This is because we have a coupling effect between this rear wall and the side wall. It's something that we'll talk about later on, but it's not terribly detrimental because there's ways that we can solve this. But we can mitigate that boost. We can kind of reduce that boost by 5 or 6 dB by not putting it right in the corner. We want to try and find the left and right symmetry of the axis of the room. So again, try and sit in the center if you can, away from other surfaces. You wouldn't want to kind of sit here and be closer to this wall, or you wouldn't want to sit here and be closer to that wall. So being in the center can solve a lot of problems. And again, you can go onto the Genelec website and have a look at recommended listening distances for certain monitors, and that can be applied to other monitors as well. If you know the rough SPL characteristics and the SPL handling of a monitor, you can kind of work that out yourself as well. Real wall cancellations. Now, when I kind of go on site and I calibrate people's studios, this is probably it's probably the biggest bummer of all phenomena that happens when you're placing a monitor. If you have excess bass, then that can be dealt with. This can be a real issue in terms of harming the performance of your system. So what we try and do is place monitors less than 0.6 of a meter from the wall. What we try and do is to reduce this suck out effect, this cancellation of low mid-range frequencies. Because what happens is we have a speaker and the lower mid-range frequencies will diffract around the speaker, hit a boundary, and then come back. And at this point, they will be out of phase with each other. So, and 9 times out of 10, it's around about 100 to 120 hertz. Generally, your snare drum. Now, it's a hugely musical area. That area gives you definition and authority on a snare drum. So when you've got a groove of like a 2 and 4 groove, basic rock groove, when that snare hits and there's no energy there, it's such a letdown. It can be the meatiness in guitars, it can be authority in male vocals. If you don't have that there, you're kind of losing a lot of punch and definition and authority in the system. One tool that we use a lot is this Genelec acoustic tape, which is really useful. It's a measuring tape that Genelec supply. If you've ever been to one of our seminars, you'll generally see these given out, and it has wavelengths printed on the back. So what you can do is measure this distance from the back of the speaker to the wall, and it will predict, it'll kind of tell you roughly what the cancelling frequency will be. So this is quite a useful video to kind of show this effect. We've got a speaker that's placed 4 meters away from the wall, and this is our cancellation. So if I just hit play on here, this speaker will start to move closer to our boundary, and what we'll see is this cancellation start to move up in the frequency range. So it'll start off very low, we'll start to lose our kick drums, we'll start to lose bass elements, and as it moves closer to the wall, this cancellation moves further and further and further and further up. And what's interesting is when we get to here, if I pause it, kind of half a meter, between the rear of the speaker and the wall. There's so many people and so many studios where that is the default position because they're sat on a mixing console. You need space to get behind your desk to be able to get to the patch bay, for example. And this cancellation is seen all the time. If I quickly show you my webcam, what's up? Hello again. So this is an acoustic tape, and if we measure 0.8 of a meter, I'll lock that off. The cancellation we get is 112 hertz, which is pretty much where that is living, give or take. So it's a very predictable way of ensuring that we reduce this phenomenon by pushing the speakers right against the wall if you can. Other ways to solve it is to bring them further into the room so that cancellation moves further down, or we could add a subwoofer in to fill in that gap if we needed to. But for all intents and purposes, the most predictable way to solve this is to go right up against the wall. Okay, so moving on. Another way we can solve this is for larger speakers, we would put them into the wall, we would soffit or flush mount them. In this scenario, the speaker or the low mid frequencies don't have the ability to diffract around the back of the box. So what they do is they kind of see this wall, this infinite baffle, and that energy just dissipates across the wall. So what we get is a really authoritative system, a system that has good energy in that lower mid range. This 100 to 150 hertz area sounds solid and defined, and it really does make a massive difference to the perceived quality of the system that you're running. Monitor height. So monitor height can play a huge role in reducing floor reflections. We have a guide of around about 1.2 meters, which is kind of used as an ITU standard. So the International Telecommunications Union have this standard. Dolby use this as well, this height. So it's a good general rule of thumb to start with this. If you can get your monitors at that height, and as you're sitting, you'll be able to pretty much get all the information to your ears directly. You can go a little bit higher. I think I set mine at around about 130 because I'm a bit taller. Absolute maximum we've got 1.4 meters, but you can kind of play with that. And also, if you get them set, play with your seating height as well, because as you move up and down, you'll hear the frequency response start to change and things coming in and out of focus. Like I say, if you're using monitors where they don't have a defined acoustic axis, use your ears. If it sounds good, go with it, move up and down and just try and define that spot. We've got a number of accessories for Genelec monitors that allow you to raise speakers up on the desktop. We've got desktop stands here. We've got our woofer stands, which is a phenomenal system. You've got means of extending and controlling low frequency and low mid range, but also it doubles as a stand. Huge bonus there. The way I've chosen to do this in my room is I've used a couple of breeze blocks. So if you're at home at the moment and you're struggling to get anything delivered, and certainly to get out to visit any stores, breeze blocks are quite a good way to experiment with speaker height. Super cheap. You can adjust the height. You can chip bits off. And with the Genelec monitors, you've got these isopods at the bottom. So all I've got under there is a bit of rubber matting, the isopod, and that sits absolutely perfectly for me. There's no transfer through to the desktop. You can do this with bricks, but the nice thing about breeze blocks is they're aerated. So breeze blocks or cinder blocks, depending on which part of the world you're in, but they work quite well, and they're super cheap. And you might have them in the garden at the moment. You might be able to get your hands on them. But raising these monitors up makes a huge amount of difference, especially when you're listening to pianos. The lower octave of a piano changes enormously from when you're positioning a monitor on a desktop and when you raise it up. Suddenly you just get this clarity and this definition in the left hand, which means you haven't even spent any money. All you've done is physically just move the position of the monitor. It makes an enormous difference. In terms of aiming the monitors, we've got a window which is generally accepted of up to 15 degrees. anything greater than 15 degrees, then we perceive the monitor as a height channel. This can be really useful if you've got a big screen in front of you. If you're working in post-production, for example, and you've got a number of screens there, going higher with your positioning can help. The key thing is not to position them so steeply that you're getting a reflection from the desktop into listening position. But if you can kind of go above and direct, that's absolutely fine. Or if you can get your screens low down, or even on an angle like that, you can position your monitors over, and then you get this nice direct sound. Good rule of thumb, sounds super obvious, but it's amazing the number of people that don't do this, especially in post-production. If you can't see your monitors, then move them. It's so important. I go into so many rooms where the left and right, or the left center right monitors will be kind of hidden behind some screens. So the first thing we'll do is raise them up and start to angle them down. It makes an enormous difference. If you can't see them, then it's difficult for you to hear them. I'd like to talk about a piece of software that has become invaluable to, especially with me putting this room together. I've been using this for years with customers on their projects. But this is a free piece of software which anyone can use, anyone can download. If you go along to roomeqwizard.com, it's a free piece of software, and it allows you to measure frequency response. You can get waterfall plots, and you can also measure the reverberance of your space. And what I would encourage you to do is to use this as your benchmark when you start adding acoustic treatment, or you start changing the orientation of your room. As soon as you change something, measure it and see if it's made an improvement or not. Again, sounds really obvious, but instead of just throwing money at acoustic treatment and throwing it up on the walls arbitrarily, with this way you can judge the incremental improvement that you're making, and you can make sensible decisions about where you place that treatment. So you might start off with a couple of panels, and you might add a couple more, then that might just be enough to do everything, instead of buying a full room kit and then finding that 5 or 6 of the panels are absolutely redundant, that are doing nothing, or they might be doing too much. So this kind of software is really, really useful. And all you need is your current audio interface and a measurement microphone. You can take into account the frequency response of your audio interface and basically nullify that within the software. I mean, a lot of these interfaces now are so flat anyway that you will get a good benchmark result. With the microphone, for example, that becomes a little bit trickier. You do have to use a measurement microphone, preferably an omnidirectional microphone. We've got 2 options that you see used commonly. You've got an Earthworks QDC 50, which is around about $1,500, so an expensive microphone, a serious outlay. If you're working professionally in analysing rooms, then 100% go for this. It's amazing. It's a beautiful microphone, very, very accurate, a true reference microphone. But if you're working at home and you just want to get a feel for what your room's doing, if you want to add a few panels, start to kind of tweak the acoustics a little bit, then this Behringer ECM 8000, it's about 25, 30 bucks, something like that, 30 euros. They're available from everywhere, and this is a measurement that Real Traps did a few years ago, and you can kind of see between the Earthworks in red, the Behringer in blue. Yes, there's a couple of dB discrepancy between the two, but on the whole, it actually tracks pretty well. So if you were to use that cheaper microphone to create a benchmark, to kind of find out whether your acoustic panels are making the difference that you want, you can totally use that. That will work and give you a response. If you were going from room to room and doing it professionally, then yes, you need a certain standard of equipment and a reference that is super consistent. But with something like this will definitely help to improve the response when you're working at home, or you're working in a room that is not really set up for audio. So let's look briefly at some acoustic improvements that we can make. Room geometry. including changing the walls and the ceilings. That can help massively, but if you're renting, it can be very difficult to do. Adding absorption is probably the easiest method to controlling a space. Diffusion, kind of scattering those reflections around the room and kind of randomizing them to an extent, that can be really helpful. As I said in the beginning, if you can improve some of these elements, then the calibration becomes so much more powerful and beneficial. The active calibration is taking the room's response and then adjusting the speaker to reduce that impact. So if we've got extra low end in the system, we can reduce that. If we've got extra high end, we can reduce it to an extent. But these, the elements of the calibration will be far more beneficial if these elements are improved initially. So, phenomenon that we're all familiar with when we first move into a room, flutter echo. You kind of hear that kind of scattered echo effect when you walk into a space, when you clap or you speak. Really tiring, not a nice environment to be sitting in, certainly not a nice environment to create music in. You'll generally hear it in the high end and the mid-range, so vocal intelligibility, your ability to decipher reverb and ambience becomes very, very difficult. It can affect the low end as well. It can become really smeared and strange. Generally, it's hard surfaces such as glass, concrete, drywall, MDF. They will cause this. It'll be reflected sound. So as you start to move into a place, as soon as you put a sofa in there and some curtains, you hear a difference instantly. It feels much more welcoming. You want to spend more time in that space. So if you transfer that to acoustic treatment, it's the same principle. Even using things like sofas and curtains can really help. That's helped me in this room. I've got curtains in here at the moment, and they had a little bit of absorption. They just calmed the room down a little bit. And then as I add more absorbers, then that becomes much more profound. When dealing with low frequencies, it becomes very difficult. You need kind of porous materials that have much more mass. So again, sofas can help with that. But really, with a lot of smaller rooms, bass trapping can be really difficult because it's almost impossible to get something off the shelf that is thin and effective at low frequencies. So we'll discuss ways to kind of deal with that later on. Diffusion, so adding irregular surfaces to scatter sound waves and reflections can really help. This can be a more natural way of dealing with reflections sometimes. If you just suck everything out with absorption, then the room can sound a bit lifeless, a bit dead, a bit like a cinema, for example. If you've got a bit of diffusion, it can really help, especially when you're recording instruments, acoustic guitars, vocals, that kind of thing. It's generally not effective at low frequency, so this is generally a mid to high frequency solution. There's a number of companies that offer absorbers and diffusers in the same product. They can be really useful as well, especially if you're limited for space and you want to get kind of a 2-for-1 effect with your acoustic treatment. They can be quite useful. You might want absorption at the front of the room and then a bit of diffusion and absorption towards the rear of the space. We can look at optimizing the room geometry. The aim of the game with all of this is getting as much direct sound as possible and preventing room reflections from reaching the listening area. What we want to do is get direct sound to the listener before we hear all of this stuff. One way to do that that's absolutely free, we just move the listening position further forward. The more direct sound we get, the better. And this is going to be our friend when we're working at home. The vast majority of us will be working very, very near field. So what we have to do is kind of embrace that. If we try and move further into the room, that's where we create much more problems. We're asking a lot more of the monitor and we're asking a lot more of the room. Since the monitor is a known quantity, it's been designed well. We know its performance in good conditions. What we do is we just reduce that listening distance and move closer to it, and that can solve a lot of problems, especially if you're limited by the amount of acoustic treatment that you can put into a room, and also limited in terms of changing the room's geometry. So one thing that we can do straight away within a room to improve it. Generally, rooms without treatment have poor acoustics. One thing that we can do is to cut the corners. So again, we're changing the room's geometry. We're kind of reducing these corners, the ability of these corners for energy to build up, for flutter echoes, for secondary sources that distract from what the speaker is trying to produce and what the speaker is trying to tell you. I've done this in my room quite crudely. I just built a triangular frame, put a broadband absorber on the front of it, and then filled the back of it with rock wool panels, mineral wool panels. And that works quite well to kind of reduce those reflections back into the room, and it's just tamed these corner issues. So when I put my monitors in front here, I don't get all this kind of tacky sound, this kind of clacky sound that you would get from corner reflections. And that was super cheap to do, really cheap. And also, it's not going to stay there. If for example, if I was renting this room, that can just be pulled out. So if I was only there on a temporary basis, that can be thrown up, done very quickly, very inexpensively, and then you can remove it and put it somewhere else. So nothing is fixed to the wall there. That panel just sits on there and leans against it. So again, very easy way to change the geometry of your room. This is probably the biggest single improvement that you could make straight off the bat. If that's your listening position, you look left, you look right. If you put an absorber there, you're going to reduce those reflections coming back into the listening position. And this can have a profound effect on the realism, on the kind of your emotional reaction to your speakers as well. It sounds maybe sounds a little bit full on, but to be able to be moved by what you're listening to in a composition sense, in a listening sense, in a recording sense, it's hugely important. You've got to have some sort of connection between you and your monitoring. So by putting absorbers left and right, the direct sound will be more apparent. You'll have a tighter, more focused center image. Your vocals will sound like they exist and they occupy this space rather than just being kind of a ghost that lives between your speakers. If you get this controlled, guarantee you vocalists will sound much more realistic. You'll have a wider sound stage, your imaging will be improved, the depth and height perception generally improves, and your front to back imaging, your ability to perceive reverbs and delays can improve massively as well. So just by a little bit of acoustic treatment properly placed, and again, take measurements with Room EQ Wizard to see if you're in the right place, and also use listening material as well. Kind of reference material is absolutely key to assessing whether you're making improvements. Do the reverbs sound more lush? Do vocals sound more real? Can you perceive panning on drum fills easier? Are the guitars defined left and right? Those cues it doesn't have to be a technical explanation. It can be something that's very musical. That's something that I use an awful lot in when I go into rooms. I try and look for the quality of the sound, not just what the graph is telling me, but am I moved by it? Is that vocalist there? Does she feel real? That kind of thing. They're good cues, because your auditory memory isn't brilliant, but if you use your emotion, you kind of go, that vocal sounds real, it sounds amazing, I'm moved by it, and generally you're in a good space. If you've got enough space at the rear of the room, you can add diffusive elements in there. The way I've solved this was very inexpensive. I've just got a storage rack there with amplifiers and bits of equipment, pedals, and believe it or not, that really helps. The difference before and after putting that in is enormous, because I don't have direct sound hitting this back wall and coming back into the listening position. It's kind of scattered and diffused a little bit by having instruments and having stuff back there, so that can really help. And as I move back into the room, I can record acoustic guitars there and it's not too dead. Also vocals work quite well there if I hang a duvet up. So it's just being able to kind of make use of what you have. You don't always have to spend a fortune on acoustic treatment. You can use some of the elements that exist there already. If you're fortunate enough to be able to add significant low frequency absorption in there, then amazing. Behind my room is a kitchen, so I've got the low frequency propagates into the kitchen and kind of comes back. So I've got quite a good low frequency response just by chance, just by having a void behind my room. The low frequency thing in small rooms, because I know we'll get a lot of questions on it, it's really difficult to solve. My preference is to use some sort of calibration, whether it be analog filters on the speaker or some sort of correction software. But sometimes you just have to reduce the volume that you're working at. Try not to excite the room quite as much. And then a second thing you can do is to reference on headphones and get a secondary reference. But the less you excite the room, the less low frequency issues you have generally. But that's something with small rooms is very difficult to solve. But like I say, if you use a combination of correction software, or if you use a little bit of EQ on the monitors from the onboard filters, that can really help, as well as kind of learning how the bass translates and how the low frequencies translate when you move it into other rooms. Using a combination of absorption and diffusion above the listening position can make an enormous. I added a cloud above my listening position, and the difference was huge. It was night and day. The quality of the imaging improved. The tone of my voice changed as well. It kind of became more balanced. Noticed it when for kind of recording kind of guide vocals, that kind of thing. And then towards the rear here, I've got some diffusion. I'll show you a slide. Yeah. So above me now, I've got a cloud, just two basic absorbers. These particular panels are a company in the UK called Acoustics. I think it's their 242 absorber, just a nice consistent broadband absorber. It goes from 280 hertz upwards, so it kind of works on a lot of frequencies and it works quite nicely. Companies like Acoustic have their cinema rounds, Art Novian have their Anders broadband absorber, Prime Acoustic have their kits. They all kind of do a job, and they work quite well. So having them is way better than not having them. But like I would say, use them in conjunction with some software just to get a feel for what they're doing. So I did exactly this with Room EQ Wizard. So on the left, this is the room, the RT60 measurement before the cloud, and this is after. So the RT60 measurement is something that we can use to determine how reverberant the space is. So if you were to kind of clap in a church or a cathedral, you'd have a really long decay that would be seconds. In a small room, it may be a second, or it might be a millisecond, or 2 or 3 or 4 or 5. It's generally agreed that a good listening room for music or for speech would be somewhere between 2 to 4 milliseconds of decay. And the RT60 is a measurement from when the pressure is induced into the room to the time that it takes to reduce by 60 decibels. So this measurement here has reduced it from like 3 milliseconds down to kind of 1.5, which made a huge difference in terms of intelligibility of speech, the imaging, how realistic the phantom sensor was. It was just a huge difference relative to the amount of effort that it took to put the cloud in. So this is something that's really worth experimenting with. You can also build clouds with basic timber frames and filling them with rock wool, and then experiment with the height as well, how far they drop down. But it's a relatively inexpensive, easy way to kind of be able to just tame your room and make it feel less reverberant and live. Final section of this, I'll talk briefly about calibration. I'm going to do a webinar which is solely devoted to calibration, because there's a lot of, it's a bit of a dark art really, and there's a lot of things that you can kind of do to improve or make your system worse regarding calibration. But it's something that us at Genelec are very passionate about. Just putting a monitor in a room and hoping that it works. We need ways that we can ensure that when our customers take our monitors into an environment, that they work. They're reference tools at the end of the day. We need to ensure that any decisions that we make on the monitoring translate elsewhere. So if we've taken care of the fundamentals of the room, the orientation of the acoustic treatment, then when we calibrate, we can actually take that improvement much further. So the first thing we should do is set the level control so that all monitors are exactly the same. I would start with that to make sure they're the same level, and then I would measure the frequency response using something like Room EQ Wizard. And it has the ability to, when you make a change, you measure again, and you measure again, and again, and again. And what you can do is overlay all of those responses so you can see the difference that you're making. And if you've gone too far, if you start listening to the system, you think, oh, it's a bit bass light now, then you could just put a little bit more bass back into the system. You could take some of that filter off if you wanted to. But it just means that you're taking control of the situation and you're deciding the profile and the sound character of your system. This also works in the digital domain as well. If you're using some correction software or one of our GLM sound monitors, this is the same approach. It's just done in a more automatic way. Something that relates to speaker height, desktop reflections. So what we generally see if you put a console or a desk in front of a speaker is a bump around about 160 hertz. If that real world cancellation hasn't sucked it out, then generally you'll see this bump. Now, the real world issue with this, especially if you're working with vocals or dialogue, is that your vocal might sound a little bit clouded or a little bit woolly and bassy. So what you would do would reach for the EQ, pull that out. When you come to deliver your mix, suddenly the vocal or the dialogue sounds really light and thin. And that's generally because of a reflection from the speaker down to the desktop. So on the vast majority of our monitors, from 8 to 30 upwards, they have this desktop control, which is very useful. With our sound systems, it compensates for this. I use that all the time when working in post-production, because in post-production, dialogue is generally where the money is made. So making sure that dialogue translates is the kind of the be all and end all. So just being aware of desktop reflections, raising your speakers up a little bit. This problem can often go away with speaker height, and also aiming. If you're pointing them down at the desktop, then you will definitely get this bump. If you kind of flatten them out a little bit and point them directly at ear height, then you will get less of this phenomenon. Finally, just looking at monitors with subwoofers and where we should place the sub. I like to go as close to a wall as possible with a sub for two reasons. It makes the subwoofer very efficient, so you get a lot more low end extension and SPL out of the subwoofer if it's right up against the boundary, providing it's not a thin boundary. Again, try and go against a brick wall or something that's really solid, and then try and position it not on the center line but off to the right or to the left. For music, if it's too far to the left or too far to the right, you will hear bass elements start to drag. Subwoofers are omnidirectional in their nature, but if it's reproducing kick drums kind of slightly higher, 80, 90, maybe 100 hertz, then you will hear that sub and your ear will be drawn to it. So try and keep it just off the center line to the left or the right, and that's a good starting point. And then don't be scared to physically drag the sub around. You'll find points where it really couples to the room. You'll find points where it sounds quite weak and sounds like it's not on at all. So being able to reference that from the listening position, either running a low tone through it and moving the sub around is really helpful, or using some software. That's really good. Another trick that you can use is you could put the sub in the listening position, put a 50 or 60 hertz tone through it, and then crawl along the back wall. Put a mark where it's loudest, and then put a point where it's quietest, and then put the subwoofer in between. That's generally a really good starting point. So again, subwoofers. Again, this is all within the monitor setup guide, which is being shared. And this is a document which is really useful for kind of home use, but it works for commercial applications as well. There's a lot of good information in there, so just take it and just try things out. Try different placements, try different placements of acoustic treatment, and you'll kind of start to see the improvements in your room. There's the monitor setup guide, like I say, which is being shared. So please feel free to download that and have a read through. There's a lot of useful stuff in there. We've got information on the Genelec website as well, accessories, all that kind of thing. I just want to thank you all for joining me, and it's been a real pleasure. Thank you very much. Thank you. Bye.